5.6 Exponential and Logarithm Equations. So I'm gonna just make two different videos, and then this video just focus on solving exponential equations. If any equation is given this way, then it's easier to solve, such as 4 to the x power equal to 64. Okay, because 64, you can just find the prime factorization. They become 8 times 8 and 4 times 2 and 4 times 2 and 2 times 2 and 2 times 2. So 64 means 2 to the 6th power, and then 4 means 2 times 2. Therefore, this becomes 2 squared to the x equal to 2 to the 6th power. And just using the property, then 2 to the 2x equal to 2 to the 6. As you see, the base, same here. Then exponent must be equal to each other. So 2x equal to 6 and divide by 2, then x equal 3. Okay, even if we have maybe 3 to the x equal to 243, the step is always finding its prime factorization. So 243 is 3 times 81 and 9 times 9, 3 times 3 and 3 times 3. So 3 to the x equal to 3 to the 1, 2, 3, 4, 5, fifth power here. So as you see, base are equal to each other. So exponent must be equal to each other as well. So x equal to 5. So this kind of case, easier to solve it. And then what about this case then? Maybe 3 to the 2x plus 1 equal to 81. So whenever you do, you need to think whether this value is this base to the something power. So which means you are finding is prime factorization, and then we want to see that first. So 81 means 9 times 9 and 3 times 3 and 3 times 3. So this become 3 to the 4th power. So 3 to the 2x plus 1 equal to 3 to the 4th power. Okay. So now we just check that base are equal to each other, which means the exponent must be equal to each other as well. So you can set up 2x plus 1 equal to 4 and minus 1, then 2x equal to 3 divided by 2. So x equal to 3 over 2. That will be the answer for this question. So now, another question here, maybe 4 times 5 to the x power equal to 64. Okay. So unlike other previous examples here, this case we have a number time exponent form. So you need to isolate this exponent form first. So you divide by 4, then this cancelled out. So 5 to the x power equal to, this become 16. Okay, now if we find out its prime factorization, 16 means 2 times 8, 2 times 4, 2 times 2, which is 2 to the 4th power. So it doesn't match the base value. So we cannot apply this kind of concept which we used before. So in this case, we want to isolate this x value. Okay, then how to isolate x value? Yes, we have to use logarithm. So x equal to log base 5, so 2 to the 4th power, which is 16. as you see, we cannot find this value directly, so you have to use changing base property and then input into the calculator. So we can find out this value using the either ln 16 over ln 5 or log 16 over log 5. If you calculate this value, then you will get 1.7227. That will be the answer for this problem. Okay, so I'm gonna cover one more, and then we are gonna move another case here. What about 1000 times e to the negative 4x equal to 125? So as you see, this one already number time exponent form equal to some other number. So you need to isolate this term alone. Therefore, I'm gonna divide by 1000 both sides. If you do it, then this become e to the negative 4x equal to 0.125. So, because the base is e, so you can rewrite this negative 4x equal to ln 0.125, and later you divide by negative 4, then x equal to ln 0.125 over negative 4. So if you calculate ln 0.125 divided by negative 4, then you will get 0.5198. You estimate this become 0.52. Okay, so the last type of question which I want to cover on this video, which is like this one. E to the negative x squared equal to e to the x squared minus 4x. Okay, fortunately, we have exactly same base value. So again, if base are equal to each other, then exponent must be equal to each other. So we can set up negative x squared equal to x squared minus 4x. So I'm gonna gather everything to the one side. So plus x squared, then 2x squared minus 4x equal to 0. And using factoring, then 2x, then x minus 2 equal to 0. And solve for both case. So 2x equal to 0 or x minus 2 equal to 0. So x equal to 0 or x equals 2. So that will be our answer for this problem.